Welcome back to the ENE 310 exam preparation videos. So this video will cover an example for study unit 8 and it'll be a Schmidt trigger. So the Schmidt trigger here has supply rails at 12 and negative 12 and a V set of 2 volts. So the questions would be, if Vref is equal to 0 volts, right here that's Vref. Specify values for R1 and R2 to obtain threshold voltages at plus minus 3 volts. And if R1 and R2 is equal to 56K and Vref is now 2.5 volts, calculate the new threshold voltages and sketch the VTC curve for this. Okay. So first of all, if our saturation voltage is at 2 volts, this means that would be 2 volts, and that's VCC. So that's what the saturation voltage means. It means that you can reach a maximum of 2 volts lower than the supply before you distort your output signal. So using that fact, we've got our output is equal to a maximum of plus minus 10 volts. So therefore our threshold is equal to R2 over R1 plus R2 times 10, because this is a non-inverting. It is a non-inverting. Yeah. And because we want our threshold to equal to 3.3, we set R2 over R1 plus R2 times our output is equal to 3.3. And then we realize that R2, the ratio of R2 to R1 plus R2 is equal to 0.33, which is equivalent to 1 over 3. So therefore, you can set your R2 is equal to 10K and R1 is equal to 20K. Or you could have chosen any two values as long as you've got a ratio of 1:3 between the two values. And that is how we get values for having the threshold at 3.3 volts, right? So for here, if you were told that R1 and R2 are equal and you're asked to calculate your threshold voltages, this, let me illustrate this a little bit more. This 1/2 ratio is basically R1 over R1 plus R2. I just wrote it simply as 1/2 so that it just simplifies our equation. So your threshold is equal to R1 divided by R1 plus R2 into Vsat minus Vref plus Vref. I decided to choose this question because in most cases you usually assume that the Vref is equal to 0. But if the Vref is a different value, then that changes the way you are going to, the way your VTC curve is going to look. Because when you have a value for Vref, that means that it doesn't have equal thresholds anymore. So that is why when I came across this question, I decided, whoa, this is a good one. This is a good one just to make the brain flow, just expose you to different things. It's a big world and there's many different ways to ask the same question. So after all of that, we get the Vref, the positive Vref, to be 6.25, and using the same formula here, we get our negative Vref to be negative 3.75 volts. This isn't really too difficult. It's just that the one thing, when your Vref is not equal to 0, you must include it in the equation in such a way. And then drawing the VTC curve is pretty simple. It's just it's a copy paste from the book. It's just that you have different values for here. And that's your VTC curve. There's really not too much to this question. The way you would get your marks is your arrows, which is a nice color like blue. I like blue, turquoise. I think it's turquoise. So you get a mark for your arrows, then you'd get a mark for your V threshold, and then you'd get your mark for considering that for your maximum and your minimum output, because it was stated that there was a V saturation, so you'd get a mark there, and that's like a mark here, a second mark there, a third mark there, and a fourth mark there, and oh yeah, and the fifth mark for your arrows. And yeah, that's basically how they would mark your VTC curve. Yeah, this is really simple things, and yeah, this is your shoe trigger, and yeah, that is pretty much it.